Hey everyone, I wanted to go over how we can build our own materials from scratch. And so to do that, I'm going to start out with this scene, just kind of showing you the basic material and then how we can tweak different values in it to get more results that match real world surfaces. Okay, so I have a pretty simple scene with some primitives. First thing I'm going to do here is just assign a material to each of these um, different objects. So I'm going to hit the M key. Remember, you always want to rename the default one, so I'll call this the walls, and I will give it a color of white. We'll call this one, we'll just call them by their shapes, so cube. We'll make this one black. So remember, these are red, green, and blue values. You don't have to worry about the other ones right now. We'll talk about that in a second. Alright, sphere. We'll make this one red. Cone. We'll make this one green. And all I'm doing is clicking and dragging here. Okay. Torus. This one blue. And then cylinder, we'll make this one a gray. So I'll actually just click on that, select that, hit OK, hit OK. And I'm gonna pause just to pull up that window, though I don't think we'll need it too much. Okay, so I meant to make this blue and it didn't seem to take, so I'm just gonna select it, hit the M key again, and change this to blue. Like that, hit OK. This one I'm going to rename cylinder and make it gray. Okay. Now let's go back over to the render panel, or render layout rather. And then we're going to just discuss this really quickly. So when we use the M key to create the different materials, we created actually what's called a material group, which is this icon with the red and green spheres. The green's more of a checker mark or checkerboard green. And then inside that there's a material item, and the entire material group is assigned to the object that we had selected, right? We were in object mode and we assigned these materials, so it's on the entire object. If we hit play here, we can zoom out and look at our scene. And all of these different objects kind of have the same kind of look to them. The colors are different, but the feel of the material is kind of the same, kind of this like plasticky, rubbery look, right? And that's because of the other properties of the materials, which we're going to go into in this video. The other thing I want you guys to know is that there are a couple of other fields in this render or shading tree. The top one has the important thing here is that it has your frame resolution, which is what your images will render out at. You can change this at any time, so you don't have to worry about it when you're starting out, but if your computer is very slow, you might want to drop this down to a smaller value, just so that it doesn't have to pretty much calculate as many pixels. Right. Underneath that, we have a field for your outputs, which I don't want you guys to be too concerned with. Then we have a base shader. Now, the base shader has some important properties. It kind of controls a bit of all of the other materials and just like what's visible. And the important part in here, I guess, is really just the visibility thing for now. You know, we have options to like add fog. And you can play around with this if you want, but we're not going to get into that right now. And we have light linking, which says only let certain lights affect certain objects. We're not going to get into that right now either. But this part is kind of interesting just from a what is rendering aspect. So this is kind of telling us what is visible to the camera, right? Like, is this entire scene visible to the camera, yes or no? Is the scene receiving shadows, yes or no? Is the scene casting shadows, yes or no? And you can see that turns off different things in our scene, in our render rather. We have kind of the option to add a base shader to any of our objects and then individually control, like, is an object casting a shadow, is an object receiving shadows from other objects in our scene, things like that. That all kind of lives here. Not super important for right now, but if you want to quickly play around with it, that's where it is. All right, and then of course we have our actual materials. We have our lighting properties, which is also a type of material. Down here, light material. We then have our environment, which is currently this entire kind of gray gradient background, right? That's the default. A couple of things about this, and we'll get more into this during our lighting lecture, but if you want to completely turn off your lighting, you not only have to turn off your environment, but you have to turn off that directional light in your scene. Usually people think, oh, I turned off the directional light, and they forget to turn off the environment light, so why is there still light if my only light is off in my scene? Because this environment light is essentially giving you light from every direction in your scene. Okay? So just keep that in mind for now, and for this first project, it's kind of fine to just leave the default lighting on as it is. We'll get into custom lightings for the next project. Okay? So, let's grab one of these objects. We'll go with the sphere, and we'll just walk through some of the properties on this object. Okay? So, you can see in this mode, when I select the item here, it's automatically going to try to select the material that's on that item, and the properties page will bring up the material properties instead of just the object properties that we see in the other layouts. Okay, so we have a bunch of properties, of course. They're broken up into tabs. The ones that we're concerned with when we're doing our shading is really the material ref here and the material trans down here. Okay. These settings are split up by how light interacts with the surface of our object. So material ref is kind of how material, or how light reflects off or bounces off the surface of the material, and material trans is kind of how light goes through the material, like how it will affect the inside of the material, if at all. All right. So there are a couple of different shading models in Modo, and they all have different settings and, you know, different ways to control things. We're going to be looking at the physically based model, but a lot of these options are the same in the other models, and you can go through the options for them. One thing to note right off the bat is if we hit help and activate help and click on the material object, we should get a window with the documentation for this object. And actually, this is one of the most useful documentation pages, only because for a lot of the options and the values that we're about to discuss, they actually, or rather for every value, some of which we're about to discuss, they actually have kind of an in-depth understanding of, or like explanation of how it works. And for a lot of those values, they have different examples. So like diffuse roughness at 0%, 50%, or 100%. And so this will be very useful for you guys if you're just starting out. You know, good place to look. But we're going to cover the important or most useful values right now. So let's get into it. When we hit the M key on these, we have a couple of options here. We have the color, which is going to be your diffuse color. We have your diffuse, which is the amount of that color that's being placed on the item, essentially. Then we have a specular value, and that's going to be essentially how reflective your object is. All right, so just so you know, those correlate to 1, 2, and 3. Okay. So, whoops, I hit OK, so that applied it. I'm going to undo that. And we're just going to look through these. So first, we'll see the diffuse amount. That's going to be, again, how much of this color is applied to your item. So if I set this down to 0, we're going to get black. And if I start to increase it, you'll see this color slowly approaches this color, right? A couple notes here. A lot of these values can pass 100%. And if you do pass 100%, chances are you'll end up with a material that really can't be replicated in the real world. But you can see in this case, it doesn't really have much of an effect after 100%. Right? The diffuse color, like we just saw, is the color. If you click on it, you can change whatever color you want, and you can change how light or dark it is. If you want to go back to black and white, the quick way to do that is to click here, drag over to one side to go to black, and then drag over to the other side to go to white, or anywhere in the grayscale. Okay. And if you of course want to change your color, you can do that. You might see this screen picker item here. That's a plugin I have. I can show you how to get that if you need it, but it essentially lets you click and drag to kind of select any color that's on your screen, which is nice. I'll put a link to that in the video description as well. After the actual color here, we have some options about the reflection. So by default, we have a specular amount of 4. This value is pronounced Fresnel, and it's going to be kind of a ratio of how reflective the surface facing you is compared to how reflective the surface kind of perpendicular to your view is. That angle is called your glancing angle in most cases. And actually this sphere is a good example to see this. You see there's some white like highlights around the edge here, right? If I set my Fresnel value down to 0, we lose all that, and now the edge is no more reflective than the actual front facing section is. So I tend to usually set that down to 0 and then bring it up as I need it, because I feel like that outer rim or halo kind of makes the objects look a little odd. But there are physical materials that will have that property, so just keep that in mind. The specular amount, like I said, is just your reflection, and you can see as we get closer and closer to 100%, this becomes kind of a chrome ball, reflecting everything in our scene. And you'll notice right away that it's not a clear reflection. We'll get back to that in a minute. For now, I'm going to drop this back down to 10%. We also have a specular color, which is saying anything that's being reflected in this object, give it a certain color. Usually that's going to be white, but if we wanted everything in the reflection to have a green hue, even though we have a white light hitting the scene, the reflections are kind of tinted green. I'm going to undo that once, and we're going to look at this roughness value. So the roughness value is going to either make your object look very shiny at a low value, or kind of velvety at a higher value. It's not really going to imitate a texture. It's going to kind of distribute the light more so that it kind of looks felty or velvety, right? And you can of course go anywhere in between to kind of get a different roughness. And you'll notice that if I go back to my chrome ball here, 100% specular, and then I bring down my roughness value, I'm going to get pretty much a mirrored object. And what's kind of cool about this is that by default Modo will calculate a couple of reflection bounces. So if, for example, we were to have, let's take this cube here, we're going to change its specular amount to 100%. We're going to change its roughness to 0%, so it's kind of the same mirror type object. And we're going to just scale that down and duplicate it and put it over here. Let's actually put it here. And we'll bring this sphere kind of, oh, did that not duplicate properly? Let me do that again. Control D, move tool. Let me make sure I'm in item mode, select the item here. Control D, there we go. Alright. I'm going to move this over and bring this down and over. And I'm going to actually, for my sphere, I'm going to go back to that material and bring the specular amount down to 0. And we'll actually scale this down a little. And if we look at this kind of through our mirror here, might have to play around with the size a little bit. First, let's move this guy into place like that. We'll make these guys a little bit bigger that way. Okay. And yeah, it will get that real world effect of kind of infinitely showing reflections of your object until a certain limit. At that limit, you'll just see it black because it stops calculating essentially, and we can change that limit if we needed to for whatever reason. But just know that like out of the box, it will do a pretty good job. I think it's something like 10 or so bounces, maybe higher. But yeah, like it's kind of cool how far you can get with some of these simple settings. Where I just have an object that's reflective and has 0 roughness. All right. Whoops, I deleted the material instead of the object, so let me try that again. I'm going to select the cube and delete it. I'm going to grab that cube and move it over. Okay. Now, just a quick note, because I know with everybody working at home, not everyone has the most powerful computers. So, if you are seeing things slow down, you might want to at some point turn off a material and then turn it back on when you're doing your final render. But turning off the material by clicking the eye icon will really help speed up your computer. Alright, let's go back to this sphere here, and we're gonna actually skip over the anisotropy values. That is a way of getting kind of like a brushed metal look. Usually it works best when you have another texture involved, and we'll touch on other textures and image-based textures later. So for now, let's skip over it. We're going to look at the clear coat amount. Now this is essentially going to say apply kind of like a glaze or coat over your object. So right now this is kind of a matte, non-reflective surface, but if I have a clear coat on it, I can add more reflection. And you can kind of use this to fine-tune a lot of your other options. So let's say like I have 20% reflection, but it's a very rough reflection, like 80%. Everything's kind of blurry. Let's actually tweak that down a little. Something like that, right? And then I want to put like a glaze layer over this, or like a lacquer over this. I can say there's an 80% clear coat, and the clear coat could still have sharp reflections, like that cone or that torus over there. Right, so you can kind of get this combination of the rough reflections on the base object and then these sharper reflections in the clear coat around it. Okay, and I don't have to add more geometry or make a sphere inside of a sphere. Just lets me do that pretty easily. I can also go the other way. I can say that my object's completely smooth, but my clear coat has a roughness of like 40%. And you'll see it doesn't do quite the same thing, but it will make that glossiness have a little bit of a blur to it. Might be a little hard to see in this object, but just know that that's there, and you can play around with it if you need to. Okay, so that is what we're really concerned with in the material rough section. This surface normal part we'll come back to when we're looking at using different maps to drive different properties for our shader. So let's for now move on to the material trans section. Okay. We'll actually look at this with one of the other objects right here. If we go to the cylinder, or sorry, the torus, let's see what we have for our options. So the first thing we have in all of these materials is this option for layering. Layering is essentially going to kind of layer materials or images or different procedural layers in the shading tree, one on top of the other, kind of like Photoshop layers. And we have options like blend mode and whether it's enabled, inverted, disabled, you know, and we have opacity. So if we, let's say, duplicate this layer object, so I'm just going to select it and Control D. Now I have two of them. And in the first one, let's actually go back to material ref. First one will leave blue, and the second one will make kind of yellow, right? So like that. And now if I look at this top layer and I go to material trans, I can turn it on and off, right? That is essentially the same as this eye icon, and you can see it actually turns on and off with it. I can invert that layer. The yellow would become a blue. I can, let me actually change this color just so you see the invert. So the white would become a black if I invert it, right? Let's go back to that. I can also change the opacity, how visible this layer is, right? So if it's like 50% visible, it's 50% of that yellow on top of that blue. I can also change the blend mode, so I can, let's go back to 100%. And I have pretty much the same blend mode as I have in Photoshop, so if you played around with these, you know, it will just do the same math on that layer, right? Usually I find that most students, especially when they're starting out, don't tend to play around with this too much because usually you don't need to. You can usually get what you want with a single layer, but this layer option is available in all your types of layers, whether that's images or procedurals or just constants, gradients, things like that. So you know, that is an option for all of these layers. For now, I'm just going to delete that second material layer, go back here, and come back to my material trans panel. Now, this value here is, of course, transparency amount, and it's going to be how transparent your object is. So if I start increasing this value, you can see I start to see through my object, right? Now, underneath that, we have the transparency color. So if you want to have like a very transparent item, let's say it's like 90% transparent, right now it still has that blue, and I can actually just set my diffuse value to 0, and now it's like a clear color, right? It's not really using any value here, it's just no diffuse color. And then I can use my transparent color underneath here to kind of get a colored glass look, right? It's what color are the objects that are transparent, and this will actually also affect the color of the light going through the object and on whatever surface it hits. So that kind of works out of the box. And yeah, in this section, just so you guys see it, like a very kind of dull color here will get you pretty far. You don't have to jump all the way to a saturated color, as I see a lot of students do when they're starting out. Now I'm going to go back to white here, but you'll notice that it doesn't quite look like a transparent plastic or glass. It looks more like it's got some kind of issues with it, and that's because of a couple of values. So the reflective index is what's going to do the most for you. It's, you know, the IOR, or index of refraction, is going to calculate how light bends through the object. What's kind of nice here is we have a couple of built-in values. So if you click this down arrow, you'll see right now it's set to 1, which is air. So it's like this object is made out of air. 1.2 is carbon dioxide, and you can see right away it starts like bending whatever's behind it, or the light starts to bend and calculates like the light's bending, so you see things that are behind it get distorted. I'm going to go back to 1 here so you can see how that's perfectly the right shape, and I'm just going to actually click on this arrow to slowly increase that value, and you'll see like with each increase it's going to change how distorted things behind it are. Now at some point you'll notice that it will also reach this kind of limit where it's going to give you black in your refractions. So just keep that in mind. If that value is too high, we might need to also go back in and bump some values that kind of control how refractive things can get. Okay? In this case, I'm not actually sure if that's hitting. Yep, I thought that might be a refraction from the cylinder, but yeah, it is hitting some limit at that value. Okay, so that is our refractive index. Let's go back to like 1.2. Now, before I mentioned that you can kind of make colored glass using this value here, underneath that color you have an absorption distance value, and that is essentially how far into the surface does light have to go before it hits this specific value. And when it's at 0, it means that light's immediately going to hit that value. If you start increasing this, you'll see suddenly a pretty drastic change in your object. And this is saying, you know, let's actually go to 0.001, so 1 millimeter. 1 millimeter into the surface, we're going to hit that color. So the further we go, the more we're going to, or like the redder it's going to essentially get. So if I start increasing this value, probably quite a bit because I'm still at millimeters, yep, you're going to see that light needs to travel further into the object before it reaches that color, and essentially it's going to make it a little bit more dependent on the thickness of your object to reach that color. Usually where I've seen people use absorption distance is like when you're making a pane of glass and you want the edge of the glass to look kind of greenish, even though when you're looking through the surface of the glass it's clear for the most part. Things like that, where at certain angles light will kind of color the glass or transparent object differently. That's usually where I've seen people play around with the absorption distance, but usually you can keep it at 0 and get a pretty good result. Alright, let's go back to white. Now, dispersion here is basically going to say, take the light color that's hitting my object and break it down into its components. So we have white light, which is made of all the colors of the visible spectrum. And if we start increasing this value or use one of the drop downs, we're going to start to see, first of all, it's going to give you a bunch of colors, but as the render finishes calculating, you're going to see it's kind of breaking up that light color into different bands. And right at this value, it's still very little, and you can see that it increased by like 0.001. Let's kind of do a drastic change, something like that. And now we should definitely see, like here we have this kind of gradient rainbow color going through our objects. It's mostly going to be visible wherever the light is or wherever the object is curving, because light is going to kind of enter and exit out of that surface kind of more sharply. But yeah, it can kind of give you really cool effects. This is one of those other things. So reflections, refractions, and dispersion will all kind of increase the amount of time it takes to render. So while it's really cool and totally fine to have in your final object, I tend to like figure out my value, maybe mark it down somewhere, or turn off the shader when I'm working on some other part of my scene. All right. Now let's actually set this down to 0 again. We had the reflection roughness, which kind of made everything distorted or blurry on the surface for the reflections. So we have a similar option here for the refraction roughness. And that's going to essentially do the same thing for anything that's being refracted through the object, right? So now all of those things are kind of blurry, right? Let's actually move this object over and take a look at this. Okay, so we have like this blurry refraction of this green cone over here, right? If we were to actually add in more reflection on this object, let's actually make sure we're on the right object. Change my Fresnel value to 0, change my specular amount to like 80, and change this roughness to 0. Actually, the 80 might be a little too high, so go somewhere like that. So now we can combine like a very smooth, 0 roughness, smooth reflection over here, but still have these kind of blurred out refractions, and makes like the object feel like it's made of something, or it's like a dirty glass, or some kind of polluted, impure substance. And so you can get a lot out of just those values alone. All right. Underneath that, we have an interesting value called diffuse amount, dissolved amount. This value is essentially saying how much of this object is made out of air, like how much of the object exists. So at 0%, it's kind of like a solid object, which, to be honest, nothing in the world is. But there are some materials, like some of the space age materials, that can hold a lot of weight, but are not made up of many particles, that are like 90% air. Like another common example are the contact lenses, where the majority of that material is actually just air. Like, um, this is kind of that value, and I've seen a lot of people use it to do like transitions, but it's not really your transparency. Just keep that in mind. There's a difference, and if we look at just playing around with this value, you can kind of see it's not really your transparency. It's kind of like saying how much of this object is not actually physically the object, but rather air. If we go to like 80%, you have this kind of haloing effect, and you'll notice that like if I do have some transparency here, the refraction will still work on the transparency, but even though it's like 80% of nothingness and almost completely quote unquote transparent, it's still going to not really apply that refraction as much as you would normally expect with like a 80% transparency. To be honest, I have not seen a good use for the dissolve amount in any student work yet, but it's there if you want to play around with it. Right. After that, we have the subsurface scattering properties, and we're not going to get too into subsurface scattering. I'll show you an example of it later, but essentially it is saying if light is going into my object, if it had to bounce around through whatever that material is and then come out of the surface somewhere else, how would that look? And a good example of that is usually like human fingertips or human ears or wax, milk. So let me actually just pull up an example here. So right here, how light goes into the object. It doesn't just come out through the other side. It kind of bounces around in the surface and then comes out at different angles. So that is a whole section dedicated to faking that look and, well, calculating that look. We're not going to get into that right now, but I will show you an example in a bit. And then after that, we have this luminosity section. And the luminosity section is essentially how much light is this object emitting and what color that light is, right? So if I was to turn off my directional light, and let's actually turn off my environment as well. I have pitch black. I select this cylinder and I say it's emitting a little bit of light, right? And you can see a low value is going to add a lot of light to my scene. And here I could change what color that light is, regardless of the color of the object. And if I was to set this to something like 1, you'll see it starts illuminating my scene quite a bit. Now, just off the bat, you don't want to start using this to light your entire scene. Like, you want to actually use light objects like the directional light. But the main reason you don't want to just use this to light up your scene is because the shadowing and like the information as you get further from the object is going to get like muddy splotches like this over here. And that's going to, it would take a lot of work and processing to get a clean result out of it. So we don't want to rely on this as our main source of lighting, but it is there if an object needs to be illuminated and add some light to your scene. If you're using this in conjunction with your regular lighting, then you might be able to get rid of some of the muddiness. Right now this light's just too bright to deal with it right now, but we'll look at it a little bit more when we talk about lights in specific. Now, to be honest, most materials that don't have too much detail can kind of be faked with just these properties. One thing I did want to cover was about how glasses will calculate in this scene. So I'm just going to throw in a sphere, and on this sphere we'll put a new material, glass sphere, and we will hit OK. Go to its material properties. We'll change this back to 0. Well, actually, we'll just change the diffuse amount to 0. And we'll go into material trans. We'll go to like 98%. and we'll give this a refractive index of zinc. Let's actually go with something a little less, like water. Okay, so right now, if this was supposed to be water, right, it doesn't have to be glass. If this was supposed to be a sphere of water, the program is going to calculate this as, actually let me just turn all this off. I'll put this up to 20 and I'll drop my roughness to 0. Alright, so the program is going to assume that this is a ball of water, right? If it's calculating how light bends through it, it's calculating how light bends through the entire ball of water. If, however, this was, let's say, an empty sphere or a shell of a sphere with air in the middle, we would want to give this object some thickness. So if I hit F2, go to my polygon tools and thicken, click in my viewport to activate it, and give it a thickness, you'll notice now I have a very different result with this edge kind of being shown here. And every property of this will be calculated slightly differently, right? Like you see there are 2 layers of the reflection, actually 4 layers of the reflection, right, of this cylinder. So you have it on the outside, you have it kind of on the inside there, then on the other side of this as well. Let's actually rotate this way and let this calculate for a second. So we have 1 layer there, another there, and another there, and you can see 1 more right around it. You also have this coming in from the refraction, and you know, for an object that literally had just these values changed, and let me go right back to the right sphere. So we changed a couple values here. We turned diffuse to 0, and we just added a 98% reflection, 1.33 refractive index. That looks like a much more complicated material because it has this layer of thickness, right? So if you're making something like a fishbowl or like a snow globe or something, and you want to have stuff inside it, and you want a realistic looking glass, make sure that your glass has thickness, because remember, by default, all of our objects are kind of have these infinitely thin walls, and all of our objects are calculated as being as thick as the entire object is. Right? So it's just something to keep in mind, especially when you're working with your material trans properties. All right?